Hello everyone, welcome to UAED channel today. So today we will discuss the differences between AC and DC quantities. Even though this is very simple topic, this is very important because in day-to-day life you will work with several AC sources, DC sources, and also you will work with several AC and DC instruments. Therefore, we need to know the differences between AC and DC quantities. By definition, the DC quantities, the electrons flows only for one direction, either positive to negative or negative to positive, depend on the sign convention we use. For positive charge flow, we call current flow. That's happened from positive to negative terminal, and electron flows in the opposite direction. Similarly, in AC quantities, you have both directions, the electron flows. The way we represent DC quantities, we can mark like this, that DC voltages, positive, negative, or positive, negative like this. And AC, we mark like this notation for AC quantities, positive, negative. Now, examples, AC voltages, AC current, and DC sources, DC current are the example for DC quantities. Therefore, now we can think, okay, if that's the case, now I can draw the time-varying nature for DC quantities here. Since DC quantities does not change with time, it's static value. So you have same value with time every time. What are the examples you get for DC sources? Like battery. Battery, you get DC voltage output. Suppose you get 1.5 volt battery from the shop. If you measure this voltage across these terminals, positive and negative, using multimeter or ammeter, multimeter or a voltmeter, voltmeter, you will observe nearly 1.5 volt across these two terminals. Another example for DC is solar cell. So you can expect DC voltage. Similarly, for AC quantities, you can produce AC voltages using AC generator. Now, you rotate a shaft and you have windings in the ends of the generator, and you have a magnetic field crossing on this winding, and based on that winding, you can expect a AC voltage. If this is a three-phase, we will discuss it in later, the nature of the three-phase, but for now, we assume this is single phase. Then you have only like single windings, you don't have multiple windings. Then you can have like this nature with time. Now, here you have a peak value. Unlike the DC quantity, you have this peak value only at one location. And one time instant, you will meet this value. Other times, it is different. You get some points where it goes 0. And it goes to negative value as well. In other words, y equals 0 axis. Or it should cross x-axis. Then only it is AC. That means you have both directions. Now, this peak value is there. In order to represent the AC value, we define this RMS value, which is this peak value divided by √2. I will discuss in a different video how to calculate RMS value for sinusoidal waveform. But for now, you need to remember this peak value divided by √2 is your RMS value. Now, that is the value you give for AC quantities. Now, for an example, in your house, wall socket, you have 120 volt voltage. Now, what does this 120 volt voltage mean? 120 volts voltage you get, that is your RMS value. Therefore, your peak value for the voltage is 120 times √2, 169.9 volts. This is in North America. And Europe or Asia, they have like 220 volt RMS, which means your peak value will be √2 times 220. Now, this way you can calculate your AC and voltage peak value, and you can get an idea. Now, if you know the voltage, how do you calculate the current? So that's the next question. Actually, current will depend with your load. Suppose for a simple case, I consider only resistor. If I have a DC voltage, my DC current will be, according to the Ohm's law, DC voltage divided by resistor. Therefore, if this is DC, this is a number. Therefore, you get this also DC. This is DC, voltage DC, current also DC. Similarly, if I have a AC voltage, then my current will be, I can write this is Vt, therefore my It will be Vt divided by R. You see, since this is time varying, I write it like a function Vt, and current is time varying, so I write it It divided by R. This is a number. Since this is sinusoidal or AC, this is divided by a static number, you get this also AC. Remember, so if you have voltage, your current determined by the load, how much barrier you have here. So it will start to draw this amount of current. If it is AC voltage, DC and the resistance, then you get again AC current. If it is a DC voltage source, if it is resistance is the load, then you get a DC current. This way you can calculate the current. Now, as I mentioned before, in DC circuit, your positive charges flow from one direction to the other direction, and the negative charges flows in the opposite direction. Now, current flow this way, therefore your electrons flow this way. This is electron flow direction. Similarly, in AC circuit, your electrons flow in both directions because their polarity gets reversed, as I mentioned before. I hope this video will summarize the questions you had for AC and DC quantities. In a future video, we will discuss how to calculate RMS value and how do you proceed with AC and DC parameter calculations. Thank you for participation for today's video.